Hello, folks. Okay, we are going to be talking about section 9.9, which is our first introduction to trigonometry. And for some of you, I know you already have been introduced to this, but I just want everybody to be on the same level here so we all know what we're talking about before we move into the more difficult stuff. Okay, so let's just define what sine, cosine, and tangent are. They are trigonometric ratios for right triangles. And if you remember what a ratio is, it's a comparison of two or more numbers. So what we're going to be doing is looking at two sides of a right triangle and writing it as a ratio. And depending on which two sides we're using and which angle we're talking about, it's going to either be sine, cosine, or tangent. So for the first thing I want you to hear is to look at this right triangle and the way that it is laid out with you or for you with all these letters. So what you need to understand is that the capital letters are always going to represent angles, and the lowercase letters are going to represent the sides that are opposite those angles. So when you see side A right here, it's opposite angle A. And then when you see side C, it's opposite angle C. Okay, and then the last one, of course, angle B is going to be opposite side B. That's going to be really important to understand because it's going to be the relationship between the sides and the angle that you're talking about. Okay, the other thing that I wanted to mention here, the SOHCAHTOA, a lot of you probably have heard this before, but it is a way for you to remember which sides go with which trig function. So the S here stands for sine, the C here stands for cosine, and the T here stands for tangent. And then the O and the H and the A, those represent the opposite, adjacent, and hypotenuse sides of the triangle. So let's go ahead and formally define sine, cosine, and tangent. So first of all, we're going to be dealing with angle A right here, this angle. And when we talk about the sine of an angle, so usually this is like a measure, maybe it's 30 degrees or 82 degrees, whatever. The sine of this angle is equal to the ratio of these two sides. And they say the opposite divided by the hypotenuse, or opposite over hypotenuse. So when they're talking about opposite, they're talking about the side that is opposite of the angle. So you look, here's the angle and it's pointing towards that side. So that is the opposite side. And then the hypotenuse is obviously the hypotenuse, which is always the same. It's the side opposite the right angle. So in this case, we would say that the sine of angle A is equal to A over C. And you would actually have numbers here like 5 and 7, and you could write your ratio as 5 over 7. Okay, so let's go do cosine. Cosine, if you look at the A and the H, that stands for adjacent and hypotenuse. So we're going to talk about the adjacent side over the hypotenuse side. So once again, here's angle A. And the adjacent side is the side that helps make up angle A, right here, this side. Okay, and we're not talking about the hypotenuse because that also makes up angle A, but hypotenuse already has a name and it's called the hypotenuse. So we're talking about the other side of that angle, which is right there. So cosine of angle A is going to be B over C. Okay, let's clear that. And then we go to tangent, which if we look up here with the TOA, that's opposite over adjacent. And for angle A, once again, opposite is A, and the adjacent is going to be B. So we don't deal with the hypotenuse at all. So for tangent, that's A over B. All right, so what you need to do is you need to memorize the SOHCAHTOA. You need to recognize which angle you're talking about, either angle A or angle B, and knowing which sides are opposite and which ones are adjacent. And I think everybody should recognize the hypotenuse, right? One word of note here, we are never going to take the sine, cosine, and tangent of the right angle. That's not to say that you can't, but it's a special tricky situation, and you're not going to learn about that until you get into a formal trigonometry class, maybe next year. So we don't need to worry about that. It's always going to be either of angle A or of angle B. All right then, let's try an example here. I have this triangle, the 5, 12, 13 triangle, and we're going to figure out all of these trig ratios. So let's start with the sine of angle A. So angle A, we got to look for it, is right here. And when we're talking about the sine, we're going to be doing opposite over hypotenuse. So that means it's going to be 5 over 13. Okay, and then we do cosine of angle A. So now cosine is going to be adjacent, which is 12. That's the side that helps make up angle A, over the hypotenuse, which is 13. And then for tangent, tangent, remember, is opposite over adjacent. So that's going to be 5 over 12. All right, so the next thing we're going to do is now we're going to do all of these same trig functions, but now we're going to look at it for angle B. So now we're down here at this angle. So now when we do sine of angle B, the sine is opposite, which now 12 is the opposite side. Hypotenuse is still 13. So we get 12 over 13. Cosine is adjacent, which is the 5 over the 13. And then tangent is opposite over adjacent. So when you look at all of these 6 trig ratios that we came up with, hopefully you're picking up some patterns, you see some interesting things going on. Maybe something that you see is that the tangent of angle A and the tangent of angle B, they're reciprocals of each other. Did you see that? 5 over 12, 12 over 5. What else you could see is that the cosine of angle A is equal to the sine of angle B, and likewise the sine of angle A is equal to the cosine of angle B. And that's kind of interesting. There's a lot of weird, cool things that go on with trig functions and trig ratios and everything. We're not going to explore all of them, but just kind of interesting things to pick up. Okay, so that's it. That's all we have for the introduction to trig. Isn't that nice? Oh, I should probably get my mouse here. Okay, talk to you later.